Good morning, dear student. We will learn chapter number 2, inverse trigonometric function. As we have started that, we have started exercise 2.1. Now we continue that after question number 10. We will start question number 11. Before that, we will learn some important properties. Yes, very first, sin inverse minus x equal to minus sin inverse x. Cosec inverse minus x equal to minus cosec inverse x. Tan inverse minus x equal to minus tan inverse x. But for cos inverse minus x is equal to pi minus cos inverse x. Sec inverse minus x equal to pi minus cos inverse x. Cot inverse minus x equal to pi minus cos inverse x. Now we start question number 11. Find the values. We are given first one, tan inverse 1 plus cos inverse minus 1 upon 2 plus sin inverse minus 1 upon 2. As we have studied all the properties, tan inverse 1 plus cos inverse minus 1 upon 2, instead of that we are writing pi minus cos inverse 1 upon 2. Sin inverse minus x minus sin inverse x, same here, minus sin inverse 1 upon 2. Again, tan inverse, instead of 1 we are putting tan pi by 4 plus pi minus cos inverse, instead of 1 upon 2 we are adding cos pi by 3 minus sin inverse 1 upon 2 minus sin inverse, instead of 1 upon 2 we are putting sin pi by 6. So now equal to tan inverse and tan, we are getting, they are cancelled, pi upon 4 plus pi. Same here, cos inverse and cos, they are cancelled, so minus pi upon 3 minus sin inverse and sin cancel, so pi upon 6. Here we are getting LCM of 4, 1, 3 and 6, all denominators. We are getting LCM 12, so 12 multiply here, 4 3s are here, 12 multiplied 3 4s are 6 2s are, so we are getting 3 pi plus 12 pi minus 4 pi minus 2 pi upon 12. Simplification, 9 pi upon 12, 3 3s are 3 4s are, so we are getting the answer 3 pi upon 4, the last answer. Now we look another sum, find the values. Cos inverse 1 upon 2 plus 2 sin inverse 1 upon 2. Instead of 1 upon 2 we can write cos pi by 3. Instead of 1 upon 2 here, because of sin inverse we can write sin pi by 6. So cos inverse and cos, they cancel, pi upon 3 plus 2 sin inverse and sin cancel, we are getting pi upon 6, but with product 2 into pi upon 6, it becomes 2 3s are, so we are getting pi upon 3 plus pi upon 3 is equal to 2 pi upon 3. This is our last answer. Next sum, question number 14, tan inverse root 3 minus sec inverse minus 2. We know the property sec inverse minus x equal to pi minus sec inverse x. So here tan inverse root 3 minus, instead of sec inverse minus 2 we are writing in the bracket pi minus sec inverse 2. We leave the bracket in the next step, equal to tan inverse root 3 minus pi plus sec inverse 2 equal to tan inverse, instead of root 3 we are writing tan pi by 3 minus pi plus sec inverse, instead of 2 we are writing sec pi by 3. Tan inverse and tan, they will be cancelled, we are getting pi upon 3 minus pi plus sec inverse and sec, they will be also cancelled, we are getting pi upon 3. Here we are getting LCM of denominators 3. We put 3 multiply here, we are getting 1 pi 3 multiply here, we are getting 3 pi minus 3 pi plus 3 multiply here, cancel, so pi. So pi plus pi, 2 pi minus 3 pi, it is minus pi upon 3, that is our last answer. Now we start exercise 2.2. Prove the following sums. Question number 1. 3 sin inverse x equal to sin inverse in the bracket 3x minus 4x cube. Here we have to prove. So we can start from LHS or RHS. Here we will start from RHS. We study RHS. Look at the RHS. Here we are assuming instead of x sin theta. Instead of x we have put sin theta. Therefore first step you can see sin theta is equal to x. So sin inverse x equal to theta. That is the result number 1. Here we will use property here, that is identity. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. It is important property we have used in standard 10. Right hand side, sin inverse 3x minus 4x cube. Instead of x we are putting sin theta. Sin inverse 3 sin theta minus 4 sin cube theta. We know that 3 sin minus 4 sin cube, it is sin 3 theta. So sin inverse sin 3 theta, sin inverse and sin, they will be cancelled. So we are getting domain 3 theta. This is equal to 3 theta. Instead of theta, from the first result we can write sin inverse x. That is your LHS. So we conclude that LHS equal to RHS.